All right, in the last lesson we talked about arithmetic sequences. Remember, a sequence is a list of numbers, right, in consecutive order. So whether smallest to biggest or biggest to smallest, right, in order. Today we're going to talk about a geometric sequence. So what makes it geometric? Remember, arithmetic is when we're adding by a common ratio. Now we could be adding a negative number, so you can think about it as adding or subtracting, right? A geometric one is where we have what's called a common ratio instead of a common difference. Now, a common ratio implies that we are multiplying by something. Now, remember, when we say we're multiplying, you could be also dividing, because to divide by 2, instead of saying it as division, that's the same thing as multiply by 1/2, right? So we can rewrite anything as division as multiplication. So we're just going to think of it as multiplying. So the numbers could be growing or shrinking, right? All right, so let's look at our first one here. Here's a geometric sequence. The first number is 7, and look what's happening each time. I'm multiplying by 3, multiplying by 3. Now, anytime you want to find the common ratio, this is small but important detail, right? Because sometimes it's a little trickier to figure out. It's not, just staring in your face. All you got to do is take any number. So we use r for the common ratio, and we'll see it down here. R is the common ratio. Notice that it says Tn divided by Tn minus 1. That means take any term and divide it by the previous term, right? That's what that means. So in other words, if I take 21 divided by 7, or if I take 63 divided by 21, or if I take 189 divided by 63, in all three cases, the common ratio is 3. Okay, so that's what r is going to be. All right, so I'm just going to move it up here now that we've figured that out. And we know our first term is 7 in this pattern, right? So we can write out, the general formula for this. Sorry, I said oops because I just swiped my mouse like halfway across the room off my desk by accident. All right, so here we go. So let's write down what the general term formula for this one is again. So remember, Tn stands for the general term, right? It could be any term, and n is the term number. So term and term number. All right, so a is once again what we use for our first term. So just looking at this pattern up here again, sorry, I gotta keep kind of going back and forth. The first term is 7, so a is gonna be 7. And r is our common ratio. We're multiplying by 3 each time. And remember how you can find it, right? Again, take any term, divide it by the previous term, okay? So that n minus 1 means the term before, 1 before, right? All right, so what's this formula look like? This one's actually a little simpler to write. There's no simplifying to do. Here it is right here, right? So let's just fill in what we know. Tn equals a, which is 7, times r, and you have to put it in brackets, okay? R is 3 to the n minus 1. Now that's how you actually calculate it. So let's prove it. Let's just show how I could get 7, 21, right? So on and so forth. So let's say term 1. What's term 1? It's 7. What's term 2? 21, right? And so on and so forth. Term 3. Term 4. So just to prove how it works, let's just do one really quick here. Let's do what term 1 would be. All right, well, what's 7 times 3 to term 1 minus 1? Well, that's 7 times 3 to the 0. 3 to the 0 is 1, right? 7 times 1 is 7. It works, right? And so on and so forth, right? So that's the pattern. That's the formula. So it does have an n minus 1 up there in the formula, okay? All right. Now, what's the general term, or sorry, the recursive formula, right? That no one really cares for too much, right? How do we write it? Well, first we start by stating, like its own little formula, what the first term is. So we say term 1 is 7, comma. Then we write the second part of the formula. It's broken into 2 pieces, okay? And we say, all right, any term, Tn, the general term, any term, could be r times 3 times the previous term. So that's what that means. When we write Tn minus 1, that's the previous term, right? That's what that means. The term before, okay? Where Tn is the current term, right? Whatever term you're on. All right, so there's your formula. There isn't really much to it. All this formula says, look, here's your first term, and then this says to find any term, go 3 and then times it by whatever term came before it, right? So if you look at it, pattern, isn't that all we're doing? 7 times 3 is 21, 21 times 3 is 63. To find the next term, you just multiply the previous term by 3. And that's all this formula is trying to show us. All right, let's move on and do some examples. All right, so I've got 2 geometric sequences here, and I can prove they're geometric because I got to figure out what a is, and I got to figure out what r is, right? So a is our first term, which is 2, so that's easy. And r is the common ratio. So if I take 6 and divide it by 2, or 18 and divide it by 6, or 54 and divide it by 18, what do I get each time? Is 3, right? So there you go. So let's write out our formula, right? Tn equals ARn minus 1. All right, so any term is equal to 2 times 3 to the power of the term number, subtract 1 from it. All right, so this says find the 16th term. So instead of counting by hand, the point is we want to make sure you use the formula, that you understand how to use. Because what if instead of the 16th term we said, you know, the 160th term, okay? So I'm just using smaller numbers here, but the point, some people, like when they write their test, they don't use any formulas. They just write everything out by hand and count it out by hand. They get no credit, 0. The whole point is to use the formulas, okay? All right, so here we go. What is 2 times, oh, what do we want to do? We want to do term 16, right? Sorry, so, oh boy, here we go. Get my eraser here. Let's make this into term 16. All right, so term 16 equals 2 times 3 to the 16 minus 1, which is obviously 15. So what's 2 times 3 to the power of 15? So what you'd have to do is punch in your calculator, what's 3 to the power of 15, which I got written down here, 14,348,907, and then times that by 2. Okay, so the 16th term is 28,697,814. So these grow really quickly, right? Because we're multiplying each time, right? All right, now here's one where it's shrinking, right? What is A? A is the first number, which is 16. What is R? This is where we start getting in trouble, okay? Let's use fractions here and not decimals. Take any term, divide it by the previous term. Like what's 8 divided by 16? Or what's 4 divided by 8? Well, let's think here. You know, let me write it next to it. You know, 8 divided by 16 or 4 divided by 8. R is 1/2, right? They're shrinking by 1/2 each time. So there's A and there's R. Okay, so let's write our formula. Tn equals AR to the power of n minus 1. So any term can be calculated by taking 16, timesing it by 1/2 to the power of n minus 1. All right, so let's find the 16th term. Now, again, we want this as a fraction, not a decimal, okay? So what's 16 times 1/2 to the power of 16 minus 1? Well, that's going to be 15, so we have 1/2 to the power of 15, right? So it's really just going to be, because 1 to the power of 15 is just 1, what's 2 to the power of 15? So punch in your calculator, 2 to the 15, and we have 16 times, here, I'll just keep a bracket around it for now. Oops, getting a little sloppy. There we go. 16 times 1 over 32,768. Now, this is going to be divisible by 16 because it's a multiple of it, right? So I'm just going to go, okay, 16 divided by 16 is 1, 32,768 divided by 16, and we end up getting, calculator time, oops, sorry, before I get to that, this should say 16 here. This whole time I've been writing n, right? I'm sure some of you noticed that. There we go, because we're trying to find term 16. Term 16, when I reduce it, I get 2,048. So it's 1 over 2,048. That's the 16th term. All right, so let's do a few more examples. Okay, so remember I told you only use the recursive formula if a question specifically states it. So this question says give the recursive, no, I should say given the recursive formula. I'm giving you one. So I'm giving you a recursive formula. This is very similar to the one we did before in the arithmetic question, right? I'm just giving you a recursive formula. Tell me the first 4 terms, and is it geometric or not? Prove it to me. All right, so let's go here. So we already know the first term, right? They tell us term 1 is 5. Now, how do we find term 2? Well, think about it. We're going to replace this with a 2, right? And this would be the previous term, so 2 minus 1. So this term is going to be the previous one. 2 minus 1 is 1, so term 1. So to find any term, it's 3 times the previous term minus 6. So 3 times the previous term, which is 5, minus 6. So 3 times 5 is 15, right? 15 minus 6 is 9. All right, let's do term 3. Let me just highlight these terms so I can spot them. There's that one. There's the second term. All right, what's 3 times the previous term minus 6? What's the previous term? It's 9. 3 times 9 is 27. 27 minus 6 is 21. All right, and there's the third term. So once you realize how to read these, they're actually really easy questions. It's just the whole, and that's really the whole point, learning to read them, okay? Not really doing anything else more complicated. All right, so last one, term 4 is 3 times term 3, right, which was the previous one, which is 21. What's 3 times 21? 63. 63 minus 6 is 57. So there's your first 4 terms, right? Let's just write them out here. 5, 9, 21, 57. All right, so there's term 1, term 2, term 3, term 4. And it says, is this a geometric sequence? Well, how do we prove it's geometric? Remember, we have to take a term and divide it by the previous term. So what's 9 divided by 5? Or what's 21 divided by 9? Or what's 57 divided by 21? Are these all the same ratio? Well, the quickest way to tell is make them in decimals. 9 divided by 5 is 1.8. 21 divided by 9 is 2.3 repeating. 57 divided by 21 is about 2.7. They're not the same, right? This is not, the ratio keeps changing. So once again, I've given you one that actually isn't because I want you to see what it looks like when it's not. Because we already know what it looks like when it is. It would be the same number each time. So therefore, it's not geometric, right? Because there's no common ratio. Okay? And there you go. There's the ratio keeps changing, right? All right, let's do 2 more. So I'm just following the same pattern of what we did with the arithmetic questions. I'm basically doing the exact same questions, style of questions, just with different numbers for geometric, right? So this is following along with the example from the arithmetic one. How many terms are in the sequence? So I'm giving you a bunch, and you have to prove it using an equation, right? So what do we know? We know term 1 is 4. We know term 2 is 12. And we know term 3 is 36. Term question mark, right? What is that one? So that's the last term. So like we did before, if we can find the term number, right? If we can find n, that's what we want to do. Let's find its term number, right? And if we can find that, then term number, which is n, then that's how many terms are in the sequence, okay? So what do we know to start? We know a is 4. That's our starting one. We know the common ratio, 12 divided by 4 or 36 divided by 12, right? If I take any term and divide it by the previous one, I'm going to get 3. All right, so we're multiplying by 3 each time, right? All right, so let's sub that into our formula. Tn equals ARn minus 1. Okay, so Tn equals 4 times 3 to the power of term number subtract 1. And what we're going to do is we're going to substitute in the last term. So let's substitute the term for the last one, which is 1,549,681,956, and solve for n, and that'll give us our answer. That's it. So it's a pretty easy question. All right, so here we go. 1, 5, 4, 9, 6, 8, 1, 9, 5, 6 is equal to 4 times 3 to the n minus 1. All right, so how are we going to solve this thing? Well, first we're going to divide both sides by 4, right? Divide both sides by 4 here. That'll cancel that out, right? Okay, and when I divide by 4, I'm going to get 387,420,489 equals 3 n minus 1. Now, here's where we get into trouble. We don't want to play a guessing game at what this is. So hopefully you remember logarithms. It's been a little while. Remember how we can use logarithms to bring the exponent down. So we're going to take the log of each side. All right. And when we do that, okay, so on the first side, it's just the log of this number, right? Now, when we do it on this side, the log of 3, the whole trick with logarithms is it allows us to take the exponent and move it down in front, right? So we're going to move the n minus 1, put it in a bracket, out front. Now on the other side, you did move the exponent down, but what was the exponent up here? It was just a 1, right? So bringing a 1 down and timesing by 1, that doesn't matter, right? It doesn't do anything, so we don't bother, okay? Now, you're going to divide both sides by log of 3. So it's getting a little messy here, but we're going to go, okay, log of this big number divided by log of 3, right? Log of 3, 8, 7, 4, 2, 0, 4, 8, 9 divided by log of 3 equals n minus 1. When you do all that work, you put in your calculator, log of that big number divided by log of 3, it's going to give you 18. There you go. And all you got to do is add 1 to the other side, right, to get rid of that minus 1. And there you go. So, again, you could just sit there multiplying, right, 4 times 3 times 3. You could just keep hitting 3 in your calculator to double check it. But again, what if the numbers get really, really big, okay? And that's the point. You need to be able to show that you can follow these steps, okay? So we figured out, therefore, there are 19 numbers, all right, in this sequence. 19 numbers in the geometric sequence. All right, final one, which is going to be our system of equations question again. So I'm just going to jump right to that, and let's get rolling. All right, let me move this up here. All right, so this is the last example. It's the big one. This is the one where I'm telling you the 15th term is this, the 18th term is this. What is the last term? Or sorry, what is term 10? Or what is term who knows what? Term something, okay? The main thing though is and they told us a geometric sequence, so we know it's geometric. The whole point of this is, and it's going to say, solve it with a system of equations, okay? Not just guess and check. Can you set up your two equations and away you go, right? So let's set up two equations. Now, remember, we don't know what A is, right? We have no idea what the first term is. We have no idea what the common ratio is. So that's what we're solving for. Two equations and two unknowns, and that's what you're really being tested on in this question. Can you do that? So let's go. Term 15 is 128. Term 18 is 1024. Okay, what does our general term formula look like for a geometric sequence? Not arithmetic, geometric, right? It's Tn equals A times R to the n minus 1. All right, so we just need to substitute what we know so far into the right spots. So we're going to make the n is going to be 15, and the term is going to be 128. The n, term 18, and the term is going to be 1024. All right, so right now, 128 is a term. Don't know what A is, don't know what R is. I'm going to put 15 in for n and subtract 1. 15 minus 1 is 14. Okay, same with this one, 1024. Don't know what A and R are. We're going to sub 18. 18 minus 1 is 17. All right, so we got two equations, right? So what do we do when we have two equations, two unknowns? Generally, we use substitution and elimination, but that's not going to work here, okay? Now, if you try to subtract them, I'll show you really quickly. What we actually have to do is we have to divide them, okay? So what we're going to do, let me just write this down. Solve for R by dividing, not subtracting or eliminating or substitution, okay? That's the trick here. Why do we have to divide, okay? Because the A and the R are glued together by multiplication. So the only way we can eliminate the A is to divide it away. We can't subtract it. Now here's a tip, just to make the numbers easier, put the one with the larger exponent on top, okay? So let me just put, put the larger exponent on top when we divide on the numerator, right? Exponent on top. Okay, so in the numerator. So what does that look like? All right, so here we go. 1024 equals AR 17, because the 17 is the bigger exponent, divided by the smaller one. 128 equals AR 14. Now, let's divide, right? Again, I put the bigger exponent on top. Okay, so when we divide the 1024 and the 128. That's easy. We get 8. When we divide, the A's will cancel. A divided by A is 1, right? So that's why we divided, so we could cancel out the A. And then remember, when we're dividing our exponent laws, we subtract the exponents. So 17 minus 14 is 3. Now, how are we going to solve for the third, right? R to the power 3. We're going to use the third root. So what's the third root of 8, right? Well, what number times itself 3 times gives you 8? It's 2. So there you go. R is 2. Cool. So we got our first piece of information here. R is 2. All right, now we just need to find A. So like usual, once you have one piece, sub it in to find the other. So we're going to substitute R into either equation and solve for A. Okay. All right, so to do that, here we go. Pick an equation. Which one do we want? Doesn't really matter. I guess I'll take, I don't know. I guess let's do this guy. All right, so let's use him. I don't know why that was such a hard decision. All right, so we're going to go 128 equals A times R. We're going to replace, right, with 2, because we just found R is 2. So I'm going to replace that R there with 2. So I'm going to go, all right, well, what do we got there? 2 to the power of 14 is going to give me 16,384. And again, no decimals here, okay? We want fractions for answers, okay? No decimals accepted. All right, let's divide both sides by that amount, right? 16,384, right? You know what? I'm just going to skip to the next step and isolate A, because we're going to divide both sides by 16,000 there. So A equals 128 over 16,384. Now, reduce it. Guess what? They're both divisible by 128. So divide them both by 128, and you will get 1 over 128. So your first number in the sequence is 1/128. There you go. All right, so that's the hard work. That's where in a question like this, most of the work comes from. Actually, there's one more step for most of the work. We have to write the general term, right? Write the general term. All right, so you know A, you know R. The general term is Tn equals ARn minus 1. You just got to fill in those numbers. 1 over 128 times R, which is 2 to the n minus 1. There's your general term. All right, so that's most of the work. To finish the question, what did the question say? Find term 10, right? Okay, so all we got to do to answer that, let's finish it. Term 10 equals, we're just going to substitute, right, that into there and 10 into there. So 1 over 128 times 2 to the 10 minus 1, right? 10 minus 1 is 9. So I'm going to put in my calculator, what's 2 to the power of 9? And I get 512. Okay, well, 512 is divisible by 128. So I go, what's 512 divided by 128? I get 4. What's 4 times 1? The answer is 4. There you go. Term 10 is 4. There's the answer. Now again, the marks for this, people get obsessed with, well, I just got the 4 at the end. They show nothing. They just give me like a 4, right? I'm like, the whole point of this question is about being able to set this up and solve it, okay? All right, that's it for this week. Give the questions a try.